Okay. Okay. Now I can share my screen. Student, can you hear my voice clearly?
Yes.
Okay, thank you. Thanks for confirming. Okay, and let's see our course syllabus. We already missed one class, first class, because my Zoom account was not ready that time. Yeah, it was few glitches, and it was alive as Tuesday. I think it was evening time. It was alive. I worked with IT persons, and then they alive my Zoom account. Okay, now I think it is good to go. Oh, this is our course. Here is in home page. You may find my Zoom link. You can join by using this link in our class. And I'm not available right now in office. So if you have any questions or any comments regarding anything, I mean that if you have any confusion in our lecture or any concept, if you want to clarify any concept, if you want to discuss with regarding your course material, your syllabus, any new algorithms or anything. If you face any problem or anything, then you just contact with me by using this email as soon as possible. There you'll find the announcement. I think you know about this. And let's start from our syllabus. I'll go through the syllabus right now. So as usual, this is my email address. So when you send me an email, please use the CSE 4610 in your subject line. Otherwise, actually, I actually don't know that who sent this email, from which class I received this email. You can appoint office hour. Right now, it is by appointment. So I may actually give you some fixed time for this office hour. I'll add in here in later. So this is our lecture. It is completely Zoom. We will meet twice a week from 4 p.m. to 5:15 p.m. Tuesday and Thursday. As usual, you can use also. I put the Zoom link in here as well. Okay, this is our Canvas link. This is our advanced operating system. So you may already complete the 4600, right? Thumbs up or anything. Did you complete this 4600? This is only operating system. Did you? Okay. Okay, got it. Got it. Okay, no problems. That thing. So I will the course that I designed for you. Let's discuss that thing first. Then, if you have any question, please ask me. Okay. At first, I will give some idea about the just overview of operating systems. Also, in next, I will go. Maybe I will change this order. I'll go for the memory management. Then I'll go for the process and thread. Here I'll update that things, and then some synchronization and deadlock, file management, IO system. That is when you actually discuss about the file management, that IO, and everywhere actually I will come. I will actually we have to talk about the IO system. Also, at last at the end of the class lecture, actually we talk about the some distribution. Sorry, maybe some distributed operating system, cloud computing, and distributed computing as well. That things we will discuss at the end of our semester. And okay, so if you anybody, if you did your CSE 4600. Can you give me some idea that what you did previously? Did you learn the deadlock? Did you hear about the deadlock? Or this thing?
Yes, Professor, we did.
Okay. So did you learn the page fault or page fault and paging, page fault, this kind of stuff?
Yes.
Okay, paging. So I'll give some more time in file management, but I don't know that when you did this course. Did you do this last semester or 6 months or 1 year before?
I took it last semester.
Okay. Then it is good. It is good. Then I think you can remind almost everything. So I'll go. Okay, there is a one. I will for a while. Okay, Ramirez. I got it, Rick. I got it. So that's why actually I would like to, for the sake of this class, so I would like to actually go to just give some overview. Just again, just refresh your memory. I'll go. Actually, I would like to go through the memory management process thread, and then I will spend some more time in file management system. We'll go actually deeper in this subject in this class. Some of you may take these courses maybe 1 year before, and this is operating system course. I know we don't use actually frequently that term. If it is programming, you are CSE student, so programming you just repeatedly use this programming already in your daily life. But operating system, once you learn it, maybe you don't use it frequently. You don't have frequent class, or you don't have actually frequent reading in this topic like this. So that's why I would like to repeat some part. It may be repeat some idea, but I'll go some deeper digging some deep knowledge for each of the subject, like memory management, synchronization, and deadlock. I'd like to explain more time in file management system, also IO system, and distributed operating and distributed computing and cloud computing. This part, kind of advanced topic of operating system. So far, do you have any question, or that actually we are thinking to proceed on? Do you think is it good to go, or do you have any comment or anything? Okay, thank you. So I may move forward. This is the course schedule. So did you learn the CPU scheduling algorithm in a previous class? Scheduling algorithm, CPU process. When you actually CPU scheduling the process, there are different types of algorithm it follows. Okay, got it. Okay. We'll just go through it again, because it needs in our file management and others chapter as well. So I'll give you some again. I will actually give you some overview that what is the CPU scheduling and that kind of stuff. So you will learn the distributed operating system, computing and cloud computing, security, also disk scheduling, that times, and synchronization, process synchronization, this kind of stuff. So we'll go for some advanced algorithms in this topic. So this is the system your prerequisite for this course. If you do not have this prerequisite, it's fine, as I am just review some previous term as well. So this is the textbook I recommended. It is Modern Operating System from Pearson. you can follow this textbook as well. Now, the important part is grading. So this course, as we have only few people in this course, few people registered, few students registered in this course. So I am thinking that we will go for 2 midterm and 1 final. And midterm will be the first midterm will be the 30%, second is 30, and final will be the 40% marks. And exam will be total. I did mention that the 2 midterm and 1 final exam. Of course, it will be through the campus, and exam will consist multiple choice questions, short question, and true false related types topics. It won't be that difficult, I guess. Multiple short questions and true false. If you follow my lecture and also my PowerPoint slides that I upload in a module, then you will be success in this course. This is some university policy, and this is also important part to you. You can check your Canvas regularly, and is there any announcement or not? And if you have any emergency or any emergency cases, you can contact with me via email. And also, if you face any difficulties for any topics, please email me. Okay, if you have any in course, actually we don't have any activities like homeworks in this course, because only not too many students registered this course. At first I was thinking that I'll give some group project or group homework, but when I checked that only 10 or 12 students registered this course, so I was stick within midterm, 2 midterm and one final exam. Okay, so any question do you have? Okay. Okay, any question? Okay. Okay, so as we already I already mentioned that this is our second class or second lecture. We missed our first one. So today I'll give you some introduction regarding the operating systems. Before I go switch to the operating system, I'll just show you the modules. Here modules, you'll find the PDF as well as the PPT slide that actually cover this week, but it is not a weekly based module. Some part, you know, that some module is very big, so we cannot complete it within a week. It may requires 2 or 3 weeks. So whatever actually complete in a week, every week I give you some email message or give you an announcement that today we complete that part, and what will be next. You will check the regularly announcement that I posted on the campus. Right now we have 2 module. In module 1, I posted two slides. One is PDF format, another is the PPT format. That is no assignment. So you can go for any discussion. I open one general discussion. You can go for any discussion regarding this class. Okay. So let me stop my video before I continue with my today's lecture. Okay. Yeah. Stop here. I can find this video. Sorry, got it. Okay. So before I start the operating system, that will be the first slide. Yeah, it's slide number 4. So what is the operating system? Before I start the operating system, let's see that what is the computer system. As you know, the computer system is nothing but software and some related hardware. So how it works? These are works together to solve our problems. Problem means you try to edit a picture. So what you need? You need a Photoshop. Also, you want to write a document. So what you need? You need the MS Word software. Software means the kind of this is one kind of program. And what is the hardware in your computer? The main hardware system is our CPU, Central Processing Unit. So whatever you actually do in your computers, you did whatever you, even if you in a mouse click a keystroke, everything is managed by the CPU. CPU can CPU is aware about that. Okay, there is a keystroke, there is a mouse click, everything actually controlled by our Central Processing Unit or CPU. And another important part is memory, computer memory. Memory means there are different kind of memories in our computers. One is RAM or random access memory. Another is our hard drive or hard disks, but the secondary, also known as the secondary storage memory. And also you know, in CPU there is some cache as well as the register. So these are the memory. Okay, so how a computer, how this hard drive works together, hardware works together, that things we need to know at first. So to do this, I think if I draw a picture, it would be very helpful to you to understand. Let me open a, okay, what is the name for this website? And it's draw.io, I think, yeah. Here I can draw some picture. I already create one picture, I think. Blank diagram, create. Plus. Okay. So as I mentioned that our one computers, one part is major part is CPU, and another is another is memory. When you talk about the memory, we usually reference as RAM or random access memory. You know about this. It is called random access memory. Pure RAM. Okay, if you have any question or any comment, please raise your hand or put a comment in chat box. I'll find it. And next is our secondary memory or hard drive. Let me draw it in here. This is storage. It is called, it could be SSD, hard disk drive, or nowadays also SSD, solid state drive. So why also in CPU, I mentioned that in CPU we have some other things. It's called register and cache. We'll discuss this register and cache little bit later, but all are the storage. So you can tell me that why we use this kind of different level of storage. Let's see, in CPU, it can directly access only the random access memory. It cannot access the HDD directly. So whenever you open a program, let's see, for an example, you want to open a Microsoft Word, or you want to open a Photoshop. You click, and then what CPU does, it just check inside the RAM. If it is available inside the RAM, it just fetch it and execute the program. And if it is not available in the RAM, it just send a request to the hard disk drive, and then pull it to the RAM, and from this RAM, CPU execute this program. So from here you can see that I draw this RAM is a small size, and HDD hard disk is a big size. You know that RAM size is vary between nowadays 4 GB to 36 GB or even more, but hard drive is terabyte limit, so it is very big capacity. Their capacity is small, but this HDD price is also cost is lower than the RAM, but the RAM cost is higher. But to access anything from this hard drive, CPU to hard drive, if you open a program, let's say the MS Word program, if it is available in RAM, so CPU can execute it quickly. But if it is not available inside the RAM, it will send a request to the hard drive and pull it in here and then execute. So in that case, the trip time is very long to execute from this from a program RAM, and from a program from HDD, it's actually difference is very big. So that's why that is the reason actually. If your RAM size is big, means that you can put it here many processor program at a time, so that your computer will be faster. Now let's see that how actually RAM and HDD work together. Let's see, this is very big size, as I mentioned. HDD here, let's say here is 1000 file is available for hard drive. 1000, let's say here is 1000 or 10,000, let's say 10,000 files. For an example, it can be more. And your RAM can, at a time, RAM can actually accommodate only, let's say, 1000 file. And from here, you can see that that at a time, your RAM can accommodate only the 1000 files. But in your hard drive, you have 10,000 or say 100,000 file is available. So you may have a question that which 1000 file will be at the RAM, will be at the RAM. So then one answer can be the okay, which you can say that okay, if CPU somehow is if you know that which 1000 program will access CPU frequently, or CPU will access near future, this 1000 file should be should be at the RAM. But problem is that you don't know about the future. You don't know about the future exactly or correctly, but you can predict. So who predict this? Who predict these things, that which 1000 file from this 100,000 file, which 1000 file accommodated at a time inside the RAM? You know that the operating system is a complex software. It is not an easy software. So in operating system, it has lots of function. One of the function is called the long long-term scheduler. So in long-term scheduler, this function actually decide that which 1000 file should be inside the RAM from 100,000 file at the CP at the SSD hard disk drive. And here we can say that also from now we can we will consider the CPU as well as the random access memory. CPU, it has also limit. It can, if you consider there is only one CPU, also let's consider this is one CPU machine. Also, this is only single core. So if it is like this, from this 1000 program, CPU can access only one program at a time. If it is only one core and single processor. So again, question that who is one process will execute from this 1000 process, from this 1000 process. Okay, one more thing I have to mention in here that you may some confusion of the process and program. It is almost same. It is almost same, but most of the book it is used as an interchangeably process and program. But that is a little bit different. Let's say, let's me draw in here something. Okay, let's say here is in your hard drive you have different software. It could be the MS Word, it could be the Photoshop, it could be Google Chrome, Internet Explorer, whatever you did. It could be Team, Zoom, PowerPoint, Acrobat readers or anything. So when you click a program or a software, what it does, it will create a copy of it. So it is now in executable phase. Then when you click a program, it will make a copy of it in an executable phase, is known as a process. So if you click Microsoft One, it will click a process, let's say P1, and if you click another Photoshop, it will create another process called P2. If you create another, it will create another process for, let's say, P3. And then this copy actually move it to the RAM. And from this RAM, CPU will execute this process. If it is MS Word software, it will execute the MS Word program, MS Word software. And then if there is, if here is extra space, it will also pull the second process here, and then third process if there is space. If there is no space, let's say we have only 4, it's full. It may makes the memory full. So in here, let's say it is P4, and what it does, when it needs to execute CPU, what it does, operating system pull one process from back to the hard drive and give the access in here to him. And it is interchange. It is interchange between process executing RAM to hard drive. So how actually who decide this interchange between RAM and hardware, RAM and also hard disk? It is decided by a long-term scheduler function of operating system. We will discuss it. Actually more details in our next class. No worries about this. And from here, I also already mentioned that one process, CPU can execute one process at a time. Let's say it executes the P1 process now, and here is another two process is now in waiting phase. So who will schedule this process from RAM to CPU? It is decided by also the operating system as well. In operating system, there is another function is known as the short-term scheduler. Short-term scheduler actually decide that which process currently executed by the CPU. So in for example, it gives the schedule for the P1, and then it switches back to the P2, and then also it gives another scope for the P4 as well. These things process interchange that actually performed by our short-term scheduler. Long-term scheduler perform interchange the process between hard drive and RAM, and short-term scheduler interchange the process execution for CPU to our memory or RAM. I hope you got this point. So do you have any question? Okay, this is very almost, this is kind of basic, but you have to know about this in this course. So I already mentioned these operating systems. Okay, before I jump to the here, so from here you can see that the what is operating system does. From here, 10,000 process, it select which 1,000 process will be at the CPU, inside the CPU. So these things is done by our operating system. So from here you can understand that operating system is nothing but a resource manager. Its resource can be anything. It can be CPU. Here CPU is a resource. Here RAM is a resource. Here SSD is a resource. In that case, long-term scheduler manage the resource between SSD and RAM. But in here, CPU is a resource. So short-term scheduler of the operating system manage the process between CPU and the RAM. So from here we can say that the operating system is nothing but a resource manager. Resource can be anything. It can be a device, any device. What is the device in your computer? It is printer. It can be also SSD is a device. It can be your driver, any you can say the pen drive or stick, memory stick. Also, you can connect to your mobile phone. This is also device. Scanner is also device. Your keyboard is a device. Mouse is a device. These are the devices. Everything is managed by our operating system. In your books, the manager actually resource divided into three parts, three groups. One is the memory manager. That you already know about. That is kind of nothing but the SSD and RAM, this kind of managers. And processor manager, we already discussed about the processor manager, like the processor and between processor and also RAM. And device manager also mentioned that in device kind of different types of device, you have the printer, this kind of device which will be allocated or where you will send the signal. That things is managed by our operating systems. Also the file manager, who will give this access file, or what would be the criteria for this accessible criteria for this file, save file or read file, this kind of stuffs done by our operating system. So these are three groups, total 4 groups of resource manager. Here you can see that each resource manager is interconnected to each other. No manager cannot perform their tasks actually individually. Here you can see when you go for this is different user interface. I'll talk you later. And this is you can see this is the memory manager. It's interconnected with the processor manager, file manager. Also, it can take the help from this device manager as well. Device manager is always needs to help from the processor managers, file managers, memory managers. So it is interconnected to each other. No one cannot act as an individual. In user interface, what is user interface in your computer? So when you open your computer, you can see that this is graphical user interface for a computer, this interface. In Windows system, it has good graphics user interface. Also, Linux is nowadays you have the graphical user interface, but previously it was only the command line interface. Also, if you think about the Windows before Windows, there was a DOS operating system. Also here is also command prompt also available. This is also another interface. This is command prompt is also another interface. Oh, so user interface could be two types. Or it's the graphical user interface, or another would be the command prompt interface. Also, if you consider the Unix system, there is also command line interface. As we mentioned earlier, that each process is interconnected to each other. So apart from this manager, there is another type of managers. It's called the network manager. Nowadays, everything is available over the cloud or over the network. You can access your network drives from others' computers or any drive from your server. You can send file or process file from the server, or you can print your document over the cloud or over the network as well. Also, database thing. If you consider the database always resides in a database server. It is a remote location, so you can connect over the cloud as well as the cloud system. This is also the network managers. Well, talk about the memory management system. In memory management, main thing is the random access memory or RAM. These things. What it does, it just allows that who will get the access to the memory for a current time. Also allocating memory. Also deallocating memory. Deallocating means that whenever a process done, so it needs not to stay at the RAM. Because if you it should remove from this RAM, because if you remove from this RAM, then another process you can accommodate in that place. So whenever a process actually execution complete, then it just remove from the memory to give the space for another process. Next is you can think about the another type of memory is kind of ROM, random access memory. Sorry, read-only memory. I'm sorry, read-only memory. ROM is it is nothing but also in RAM, random access memory, it is also known as the volatile memory. You know that in RAM, it is not you just take a process or program from hard disk to RAM. It is not permanently be there. When you shut down your computers or when the process is done, it completely erased from this memory. So it is known as the volatile memory. But whatever files or anything in your computer, it is available in your hard disk drive or your secondary memory. This is non-volatile memory. It is permanent memory. So you need both of these. You need the RAM is non-volatile memory. Also, you need the you need RAM for volatile memory. Also, you need the non-volatile memory permanent storage to perform your tasks. I mean that we need to save our resources completely in our SSD or in our hard disk drive. Next is read-only. The example of read-only memories. It could be your CD-ROM, CD, CD disks, this kind of things. And here I just what the processor management does. I just mentioned in our figure that processor manager execute a program if it is available inside the RAM. This is also it does that which process will get access this current time and which access should actually move to the RAM. These things are decided by our processor manager. Next step is for device management. Device management actually allocate or give the start the device operation for any external devices like printer, board, disk drive, or it could be some when you connect your mobile phone in computers, and it also mouse, and it can be uh, your keyboard as well. These things are controlled by our device management of operating system. Device manager of operating system. So device manager of operating system. And another thing is the file management. As I mentioned earlier, that data files, everything in your computer saved as any kind of file formats. Okay, so it is kind of document type. It can be image file. It can be by any type of binary files uh, or anything. So everything is stored as a file system, as a file in a hard drive. So when when we study the file management system, we learn that how a computer system manages the file inside the hard disk drive. That things we'll discuss in our file management class. So in what is the functionality of file manager? It gives the user permissions, read only, it will be the read only or write only. Also allocate space for secondary storage, means the hard drive. So when you save a file, it should be stored in hard drive. That things is done by our file manager of operating system. Network manager is nothing but to device located at the remote location, or you can access your home printer over your Wi-Fi system. That things is managed by our network manager of operating system. Any questions so far? Okay, so let's move on to the next. Is user interface. I already mentioned this. Two types of user interface in your operating system. It can be graphical user interface or command line user interface. Also, cooperation issue. Each manager cannot perform each task isolation. They need to take help from the other manager to perform a specific task or perform any task. Because with processor manager, without processor manager, you cannot actually execute any program. But to get the data, to send the data to the processor manager, you need to help for the memory manager, kind of like this. It is always interrelated to each other. Next step is the cloud computing. Nowadays, you may heard about this cloud computing. It is very important topic nowadays. Also, lots of research going on in this topic currently. Cloud computing means that you just access a remote computer or remote PC storage or computer, especially storage, a computer, a remote computer, you can say, instead of your local server. Okay, let me give you an example. So let me give you an example that if you want to set up a new company, so what you need? You need at least a new IT company, or you want to launch a new IT company. So what you need? You need at least 2 or 3 server, one data server, one for the wherever is the code or coding part, it should be the one server. And also you need some client computers. Client means that you need some user programmers that who are actually develop software or anything. But you need this kind of stuff, at least some high configuration servers, and also some desktop or laptop PC as well. But nowadays, how it benefited by the cloud computing? Amazon, it has their own cloud service called the AWS. Also Microsoft, their Azure service, and Google Cloud also. Oracle provide their Oracle service. So by using this Amazon service, using your laptop, you just connect to the Amazon's computer, their server. You can configure your own database server or your own software developer server over the in the Amazon web services. Now you just use a one API to connect to the server by using your laptop. Then you can do it your job easily. So there are two things is related in here. So of course you have to pay to the Amazon, but compared to the whole setup, you have to buy a server. You have to buy different type of server. It needs a lots of actually money to set up initial cost. But if you contact with Amazon or Microsoft or other cloud services, you can set up actually your initial cost will be very low compared to your setup in your in-house system. Then you can just use your laptop. You connect to the Amazon server over the cloud, and you can do it. You can easily do your job. And another thing is that if you use your server in your inside your company, you always require to maintain it, whether is there any cyber attack or not. You have to always be aware about this. But if you use this cloud service, this is their job to protect your data and protect your data. This is their job. They will protect. They'll give the all protection for your company. So nowadays it is it is very popular. So many companies are developing based on this cloud computing or cloud services. So here I just show you that this is from our company. We have cloud services. Also some part here we have cloud services. This is Amazon Workspace. I just click it and then I connect to the virtual server of Amazon. Here I just log in and connect to their server in Amazon and I do my work. So this is we already mentioned that our main part of computers of course the CPU is the most important part. Then different kinds of memory, of course, with the input output devices, printer, disk drive, CD, DVD, and keyboards. Okay, this is related to your Moore's law. Moore's law is related to your computer organization chapter or computer architecture. When you study computer architecture and organization, in this subject you will find the Moore laws. What is mentioned in here, in CPU, capacity of CPU is increased twice within 18 to 24 months. What is capacity? Capacity means the transistor. A CPU is nothing but a micro transistor, very micro nano transistor inside it, billion of transistor over there. So this guy's from Intel. What is his observation in 1965 that every month, for example, this time Intel design a let's say CPU by using 2 billion transistor, and then within 18 or 24 months, it's developed the same, it's upgrade the same CPU or same size CPU within the 4 billion of transistor. So his observation is every 18 to 24 months, actually we upgrade our CPU by using twice of the transistor or capacity. If you have more transistor, means that your CPU speed is more. If it is double, its CPU speed will be become double or almost kind of like this. And so far we can see that his prediction was perfect. It was within 24 months or till 18 to 24 months, the capacity of CPU becomes twice. Now let's talk about different types of operating system. Here we mentioned that some books, this is not actually exact. Some books mention it different way. Some books it says the 5 categories, some books is 7 categories, some books it's 3 categories. So no worries about this. What is the 5 categories means that batch, interactive, real-time, hybrid, and embedded. What is the batch? Batch is nothing but our it is our initial older version. You can say the older version of operating system, very old beginning of operating system. How it's work batch system? Let me give you an example. So let me stop my one. Yeah. Okay. So in batch system, how it does, it will give select a one process to the memory and then execute it. Then if it is done, then it is back to the disk and then select the another one, and it is sent to the from here it's execute, and if it is done, then back it to the memory. This is a batch process. But nowadays, what is our operating system can perform? It can perform the multi-processing system. This is batch system is the single processing system. This is the difference, batch and our nowadays multi-processing systems. Batch can perform at a time only one process, but multi-processing system can perform more than one process at a time. It is, if you consider the single CPU, single core, then it is performed by concurrently. But due to the speed of this computer, we cannot. It seems that it is work as a parallelly, but it's perform the tasks concurrently, execute the process concurrently. Nowadays, the interactive next category is the interactive operating system. How interactive operating system does? It can, depending on the process priority, it execute the P1 first, then give the chance for the P4 to execute, and then again switch to the P3, again P1, P2. So it can work as a multi-processing system. So when it is multi-processing system, also multi-processing, multi-programming. This system is known as the multi-programming. A program can execute at a time, but it can able to switch between the process, program to process. CPU can able to switch process to process as to execute concurrently for each process. This is called the multi-programming operating system. Also, another is this is the category of interactive. Again, I mentioned that this is the category for the interactive operating system. Another is the multi-processing. Nowadays, you have the quad core, or if you have the more CPU, more than one CPU, or the core, what it can does. One CPU perform execution this one, and another is this another okay. That one performed by the second CPU. So this is for parallel processing, or it is known as the multi-processing. Since the sound like almost same, one is multi-programming and another is multi-processing. Multi-processing, and the name is the parallel processing. You need more than one CPU or more than one core. This is for multi-processing. And multi-programming, you need only one CPU and one core, but it can perform the but it can actually switch. It can mm, switch the execution process for process 1 to process 3, process 4, like this. But it at a single time, at a instead of time, it executes only a single process, or only a single program. For at any given time, it can perform only a single program or single process. This is the difference between batch, multi-process, and multi-programming operating system. Here is another is a real-time operating system. Real-time, what is the real-time operating system? It is usually used for the aircraft, or aircraft, and then spacecraft kind of like this. They are also in our aeroplane. Here they use the real-time operating system. And hybrid operating system is consist on the batch and also the interactive operating system. It is a combination of batch and interactive. How it's performed? It can perform the concurrent switching, but when execute the process 3, it's executes and then remove it and then take another one. It is kind of like this. Hybrid, that one is for hybrid system. And embedded system is nothing but in your mobile phone there is embedded, we can say this embedded also. And if you elevator, you can see one operating system. In your car dashboard, you can see that one operating system. This is embedded operating example of embedded operating systems. It can perform only the few processor, it can actually process instruction set is limited. It can perform only few tasks or few processes. So we already discussed about different type of operating system. Another is the network operating system. As you mentioned, that how network system is connected to each other. But the cloud, you can connect to the remote server. Here is your home Wi-Fi, and then router. You can get the data from the server. Also from this device, you can also send signal to the. Okay. Any question? Okay. Okay, if you have any question, please let me know. Okay, let's proceed. So from here, you can also send signal to, you can send the print command over the Wi-Fi for your any devices. This kind of system is known as the network operating systems. We already mentioned the embedded. This is a timeline of different, this kind of only theory basis. You may go through it once. It is nothing, it is not too important so far. Now we are at 2020. We have the, as you mentioned, that we have the multi-core processor, and also we have virtual machine that is connected through the cloud. This kind of things currently is available. Also in here, increase the mobility or wireless connectivity. Previously that our Wi-Fi or wireless connectivity was not too strong. Nowadays we have strong wireless connectivity, also strong network connectivity. That's why we can perform several tasks quite easily. If we for example, if we connect to the remote server, if our for example, if our Wi-Fi connection, or if our internet connection is slow, then actually it is very difficult to perform work with some remote location. Also nowadays multi-core technology is available. the processor, one processor contains the you know that quad core processor, also octa-core nowadays also available. I guess also one machine can use more than 2 or 3 processing system. I'm sorry. And then this is almost done. So RAM resources. So this is done. So let's stop in here. So before, okay, okay, let's stop here. So, and if you have any question before I go, please let me know. Any question? Okay. So today is kind of overview of it. As I think you may study it previous class as well in your TBS 4600, 4600 class as well, but you may studied it previously. You may forget the actual basic. It is very easy to actually, as a human being, to forget and to forget anything. So that's why I just go through the from the basic of operating system. In our next class, we'll talk about the memory management system, right? So any questions so far? Okay, thank you everybody for joining us.